So we have to prove that h of x is, that's if h of x is equal to f of x over g of x, then the derivative is this. That's this is called quotient rule. We're asked to prove the quotient rule. So, but before then, if you could remember, the derivative of any function from the first principle is the limit of h tends to 0 of f of x plus h minus f of x all over h. So that's it. But we are given h of x as f of x over g of x. So in this derivative from the first principle requires 4 steps. The first one, we need to get the change, that's f of x plus h. After we subtract the original, third we divide by h. Finally we'll find the limit. So we're going to, okay, let me use white. So we have h of x plus h. So we have f of, so if it's changing on the left hand side, it will be changing in the right hand side. So we've gotten this like this. So next thing is to subtract the original function from this, which is h of x. The same thing, we'll subtract, so minus f of x over g of x. So looking at this, we can get the LCM, which is g of x times g of x plus h. So here is the numerator is g of x times f of x plus h minus f of x times g of x plus h. So let's just look at what we are asked to prove. We are seeing g of x and we are seeing f prime x, but we have f of x plus h. And how will I get f prime x? Look at this. For us to have f prime x, we need to get this. So what do I do? To be able to get this, I need to add something and counter it. So if I decide to add or maybe subtract f of x times g of x, I need to counter it by adding. So this is 0 minus f of x times g of x plus f of x times g of x is 0. I just introduce so that we can get this f prime and g prime. That's the only way we can get f prime and g prime. So we'll repeat this, which is f of x times g of x plus h. So all over g of x times g of x plus h. So we are moving. Let's move to the other page. Okay. So we can factor, as you can see, we have g of x. So we have f of x plus h here. That's the remaining f of this minus f of x. So that's for this. Y for this one, remember this is minus. So if I factor minus f of x, what is left is g of x plus h minus g of x. So the same thing, we are still correct. I factored g of x and f of x. That's by grouping. So next thing, we need to divide by h. So the next step is to do this divided by h. So which is dividing this by h. So we need to do it fast so that we won't waste time. Remember this is minus, so it splits this into 2. So I divide h by h, while our denominator is still g of x times g of x plus h. So we are still correct. We divided both sides by h. Since we have minus, we split it into 2. So the LCM is h. Coming down, we'll have h, but we decided to move it up so that our solution will be easy. I hope you understand. I'm saying that, see what I did. Assuming you have a over b as one term over c. You know it's the same as a over bc. So I can move b up. So that's what instead of writing h down, I moved it up. And since we have subtraction, we'll split it. So each of the numerator will be divided by h. So that's what I did. So the next step is to get the limit. So we have the limit of h tends to 0 of the left hand side, which is that's introducing limit to both sides. So this is the same as the limit. Remember, the limit of addition, subtraction, product, division, you need to get the limit individually. So for this is the limit of h tends to 0 of gx times, we need to write this as one term now, f of x plus h minus f of x over h minus the limit of h tends to 0 of f of x times g of x plus h minus g of x all divided by h over the limit of h tends to 0 of g of x times g of x plus h. So let's still move to the next line, to the next page. Okay, we'll see that the limit of this is a product. To get the limit of a product, you find the limit individually and multiply. So limit of product is the product of their limit. And also the limit of a constant is a constant. So this is like a constant. So we can write the limit of h tends to 0 of this is g of x, y the limit of this f of x plus h minus f of x over h. Y the same thing, this is like a constant, the limit of, so we have f of x times the limit of h tends to 0 of g of x plus h minus g of x over h. The same thing, this is a constant, to have g of x, the limit of h tends to 0 of g of x plus h. So what do you have to say? This is now h prime x. That's the derivative from the definition. As you can see from what I wrote before, from the definition, do you see? So everything here is now prime. So we'll compare. So we still have that same thing here. This g of x, why this is the derivative of f of x minus we have f of x, this is the derivative of g of x over, this is a constant which is gx. If you substitute that, this, you know, the limit by the law, you substitute this as 0. So I have that same g of x, which is now g of x times g of x. So which is that. So we've proved the quotient rule. So it's a very long solution. Okay, thank you.